This is review problem number 3 for assessment number 5. It says identify the coordinates of any local and absolute extreme points and inflection points. Graph the function. All right, let's go ahead and take a look at this function. We know we can find the absolute extreme points using the first derivative. So we're going to do the first derivative here. And for the inflection points, that's going to require the second derivative. Well, let's find the first derivative. We know that the first derivative, so y prime, is going to equal negative 9x squared plus 18x. The second derivative is going to equal negative 18x plus 18. Now remember, we set this equal to 0. So we say the slope here is 0. We're looking for the roots for our first derivative. Factor out an x, or actually I'm going to factor out negative 9x. So 0 equals negative 9x. That'd be x. Factor out negative 9x from this, that's minus 2. So we end up with negative 9x equals 0, or x minus 2 equals 0. So we end up with x equals 0, or x equal 2. Now we draw a number line, mark 0 and 2, and we're looking to see, are these minimums, maximums, neither? And we want to know, where is this thing increasing and decreasing at? So we're going to pick numbers in between, left of 0, and between 0 and 2, and right of this. So I'm going to pick negative 1, 1, and then 3. Now I'm going to use my calculator to figure this out. I think that's probably the best use of your calculator, is what we're about to do. Negative 1, we're going to store it as x. Just going to kind of move this up so you can see it. Store it as x. And then I'm going to plug in negative 9x squared plus 18x. So negative 9x squared plus 18x. Hit enter. It gives me a negative. So I know that this slope here is negative. Now I'm going to store 1 as x. Pull that function back in. Positive in the middle, so increasing slope here. This tells me if I go from negative to positive that I have at least a minimum. I don't know if it's absolute, but it's at least a minimum, at least local. So now I'm going to pick 3 and store it as x, and then go back, pick that function. Negative again, so that's a maximum. All right, now I know I have a min and a max. I don't know if it's absolute or local. We'll find that out in a second. But I know that this is coordinate 0, and let's find what the y value is there. Well, I plug that into the original function. So 0 goes in, cancels out this term, cancels out this term, leaves me with negative 5 for my minimum value. I plug in 2 into this function. We'll do that in the calculator. I think that's the best method. 2 stored as x. Plug in that function, negative 3x cubed plus 9x squared minus 5. 7. So 2, 7 is my maximum point. All right, now we're not going to look and say whether these are mins or maxes. Well, actually, we can figure this out right away. So let's go ahead and do that. If it's decreasing here, so this value is decreasing from infinity, right? Decreasing slope, then it increases in slope, and then it's decreasing in slope. This can't be the maximum value because we were decreasing here from basically infinity all the way down. So this is a local max. So we're going to call that local max. And that's from 2 to 7. Again, this is a minimum, but it's got to be local minimum because this thing tails off this direction. And we know it's a cubic function, so it's going to go to infinity in either direction. So this is going to be a local min as well. That's 0, -5. And then we can say that it was, when's it increasing? Well, it's increasing from 0 to 2. Where's it decreasing? Well, it's decreasing from negative infinity to 0, union 2 to infinity. All right, it's decreasing on the at the end behavior. Okay, so now we know everything about the extreme points. Let's go to the inflection points. Well, we know we set this equal to 0. Subtract the 18, we get -18 equals -18x. Divide by -18, you get 1 is x. So this is our possible inflection point. We don't know if it's an inflection point until we test it. So here's how we test it. We plug in numbers left and right of this. So we're going to plug in 0, we're going to plug in 2. And we want to determine if it changes from negative to positive, so changing concavity, this would be an inflection point. If it doesn't change concavity, not an inflection point. So I plug in 0 into this function. This one's easy to plug in. 0 goes in for x. Gives me, that cancels, that gives me 18, so that's a positive. I plug in 2. 2 times -18, -36 plus 18, that's a negative. So this is an inflection point. So I have an inflection point. And that inflection point is at 1 comma something. Well, let's plug 1 into this equation here. If I plug in 1, I get 1 cubed, which is 1, so I end up with just -3, plus I end up with just 9 because 1 squared is 1. So I end up with -3 plus 9 minus 5. -3 plus 9 is 6, minus 5 is 1. So 1, 1 is an inflection point. I can say that this is concave up from negative infinity to 1 and concave down from 1 to infinity. That's what the plus and the minus tell you. And then finally they want us to graph the function. Well, let's do that. We have 0, -5 as one of our minimum values, so 2, 7 as one of our maximum values. Our inflection point is at 1, 1, which is right there. And so this function should look like this. Because of our negative, we're decreasing right here, then increasing, then decreasing, just like we wrote down there. And those are the solutions to this problem.